So good afternoon to all. Okay. So in yesterday's class, we are seeing that the transducers which are used for biomedical applications, and also the different types of transducers used for measurement of pressure, force, by using force summing members. We have a number of force transducers, and similarly we have transducers for displacement, velocity, and acceleration, and also to measure the pressure transducers. To measure the pressure also, the transducers are studied by using flat diaphragm, curved diaphragm, and Bourdon tube. So by using these transducers, we can convert into the force to displacement, and displacement will be measured by using displacement transducers for the force transducers. Similarly, for pressure transducers also, so by the application of the pressure, so that pressure will be converted to displacement, that displacement will be measured using displacement transducers. Now voice is audible. LE4, LE, LE11. Now the voice is audible.
Yes, sir.
Okay. So last class we have studied the different types of transducers. Okay. So today we will see the pulse sensors. We will see pulse sensors. So I will sharing my data. Okay. So today's topic is pulse sensors. So what is the need of pulse sensor? So each time heart muscle contracts and blood is ejected from the ventricles. Okay, so the heart will pumps the blood to the entire body from the vessels, causes vessels. Okay, here we have vessels are nothing but arteries and veins, and from those arteries, from arteries, will the blood, oxygenated blood will be supplied to the body, and veins will collect the low oxygenated blood to the heart. Okay, so here a pulse pressure is transmitted through the circulatory system. When the heart muscles are contracts, due to that, the blood will be pumped to the entire body, and that through the some pressure will be generated. That there is some variations in the vessels. Diameter of the vessels are different at different places, and due to that, there is some pressure will be developed, and that developed pressure we have to measure. So the pulse causes vessel wall displacement by the applied pressure on the vessels that causes a displacement while traveling through the vessels. Okay. The displacement is measurable at various points of the peripheral circulatory system. The pulse sensing can be done by placing fingertip over the radial artery on wrist or some other location where an artery is just below the spine. Okay. So here the pulse pressure can be measured by various transducers. So there are three types of methods are there to measure the pulse pressure. Okay. So if you press the fingers, you will get some pressure variations there, because the heart will sense the blood with some pressure. So when there is a pressure at the edge of the peripheral area of the finger, so you will get some pressure variations. So that pressure variation will be identified by using pulse sensors. So here we have three types of transducers. One is photoelectric pulse transducer, piezoelectric atrial pulse receptor, strain gauge pulse transducers. So coming to first one, photoelectric pulse transducer. So here the photoelectric pulse transducer is a pulsatile blood volume changes are detected by photoelectric method using photoresistors. So already we have studied the photoresistor as a uh, light sensor. Okay, so when the light falls on the resistor, its resistance will be changes according to the light intensity. So based upon that, we are measuring the principle is using here. So in this photoelectric pulse transducers are again there are two methods are used in this transducer. Based upon two methods, the photoelectric pulse transducers are developed. Two transducers that we can use. The first one is transmittance method, and second one is reflectance method. So transmittance method means when the light is applied, it will transmit through through the body and reaches to the sensor. Okay, so here, and reflectance method means the light will be reflected back to the sensor. See here, the first one is transmittance method has a transmittance method. This is the transmittance method of pulse sensing. See here, this is the lamp, and this is the photoresistor. This is the photoresistor. This is the photoresistor covered with some um, cover. Okay, and this is the finger. Okay, so you will place in between the lamp and the photoresistor. So you have to place your finger in between lamp and the photoresistor. So finger, this is the finger. Okay, so this is the variations of the blood pressure. This dotted lines shows the variations of the blood pressures, how the pressure will be changes like that. Okay, so from the lamp, the light will flows through the finger and reaches the photoresistor. When there is a variations in the blood flow or pressure, so when the blood is uh, see here, so um, okay, so light is transmitted through the fingertip of the patient's finger, and the resistance photoresistor is determined by the amount of light reaching the photoresistor. So here, so when the blood is flowing through the vessels or blood vessels, so then there is a change in the light intensity, because that blood will opposes the passes of the light from lamp to the photoresistor. In such because when the blood is flowing through the vessel, due to the pressure, the more amount of pressure will be comes, and in such situation the blood will opposes the light passing through the finger, and in such situation the resistance of the photoresistor will be increases. The resistance of the photoresistor will be increased, because the light falling on the photoresistor is decreases, because the amount of blood is flowing through the finger is more. Okay, due to pulsating nature of the blood, there is a change in the light wave, light intensity. Okay, suppose the heart is pumping like a high low like that. So when the pressure is coming to the edge of the finger, so there is some when the low pressure is coming, so we will get the high resistance, and if the blood is very coming with a high pressure, we will get the low resistance. Uh, the, Light intensity will decrease, but resistance will be increases. So there is a inverse relationship. The blood pressure is increases, light intensity decreases, and due to that, the resistance of the photoresistor will be increases. Okay, so this is the basic principle and construction of the uh, transmittance step of the photoelectric pulse transducer, transmittance method. Okay, so here we will connect this photoresistor in in a photo voltage divider formation. So we will connect it to, see here. So blood is forced to extremities, and the amount of blood in finger increases with each contraction of the heart. This alters optical density, and consequently the light transmission through the finger reduces. And according to resistance of the photoresistor increases. The photoresistor is a part of the voltage divider circuit, so which produces a voltage. Okay, so when the light falls on the photoresistor, the resistance of the photoresistor will be changes. When the resistance is changes, so it is connected in the form of voltage divider formation. When the light falls on the photoresistor, resistance will be changes. When the resistance will be changes, the voltage will be changes. The change in voltage reflects the amount of the light falls on the photoresistor. If the amount of the light falls is decreases, then the resistance will be increases, and due to that increase of the resistance, the voltage drop will be increased. and that voltage drop represents the amount of light falls on the photoresistor, and that change of the intensity will because of the variation of the blood pressure. Okay, so this voltage closely follows the pulse pressure, and its wave shape can be recorded or displayed on an oscilloscope. So uh, we can also record that variation, how the blood pressure is changing. So suppose in intensive care unit, so when the patients are monitoring, so they have to record the actual pulse rate, so how the pulse rate is changing from time to time. So according to that, the doctor will be observed what is the condition of the heart rate. Okay, so that pressure will be measured continuously. So the pressure variations, suppose how the pressure is changing. So if the more pressure is coming, so how the heart is pumping the blood, so that can be understand by the doctor. So that variation of the continuous measurement of the pulses of the blood pressure will be recorded, and it will be displayed on an oscilloscope. We can also observe in the oscilloscope by connecting the variation of the output voltage to the oscilloscope. We can also observe the how the pulses are producing, and that pulses represents the variation of the blood pressure in the blood vessel of the body. Okay, so in this way we can measure the by conductance way, uh, conductance principle, uh, by using photo. Okay, uh, and coming to the next one is reflectance method. Reflectance method. So in this reflectance method, so in the previous case, if you can observe the figure, so in the previous case, uh, the photoresistor is opposite to the finger, opposite side of the finger. So whereas in this case, the photoresistor is beside of the lamps. So these two lamps, and this is the photoresistor, and this is side by side we can place. Okay, so this is the reflectance method. The photoresistor is placed adjacent to the exciter lamp. These two are exciter lamps. These lamps will produce the light with certain intensity. Okay, these two lamps. In previous case also we have lamp, and that lamp will produce a light with some intensity. Okay, and when this lamp produces intensity, and in this reflectance method, so we will place a photoresistor adjacent to these lamps, and side by side we'll place whenever whenever the blood pressure is where it changes. So you see here, the blood saturation of the capillaries determine the quality of the light reflected, quantity of the light reflected. So so here we have some capillaries are there. In such situation, if there is saturation will be there, because when there is applied finger over the sensor, so there is blood saturation will be occurred. It means the furthermore the blood does not increase or decrease, because when you place over the sensor finger, we will place the finger over the sensor, so we will press it, and due to that, that uh, applied uh, pressing, there is some uh, saturation of the blood in the capillaries, and due to that variation of the saturation of the blood in the capillaries, there is a formation of there is reflection in the light intensity. See here, quantity of light reflected. Here, quantity of light reflected. Okay, so depending upon that, the reflected light will be received by the principle of reflectance. The light will fall on the photoresistor. So if suppose again uh, the blood will be changes, and due to that again there is a change in the resistance of the photoresistor due to variation of the blood pressure in the uh, vessels. Okay, the resistance of the photoresistor varies uh, due to the light reflection. The voltage across the photoresistor, which is connected as a voltage divider. The same as in the previous method also, we will connect this resistor in series with another resistor, and we will connect these to a voltage source. When there is change in the resistance due to the reflection of this light, so there is a change in the variation of the resistance due to the applied light intensity, and due to that there is a change in the voltage drop across the photoresistor, and that change in voltage drop across the photoresistor will be reflects the blood flow or the blood pressure in the vessel. Okay, and that is proportional to the volume changes of blood pressures of the body of the subject. Here, body of the subject means here it is the your finger. So, what is the place you can measure? So that what is the place of your body? So where you are going to measure that particular part, we can say here the subject. So here this we are using the finger uh, mm, as the object. Okay, with here we are measuring the blood pressure. So that's why finger is considered as a subject. Okay, and coming to next one is next method for the pulse pulse sensor. So piezoelectric atrial pulse receptor. Piezoelectric pulse receptor. So in this case, so we are using the photoelectric crystal. So we use the photoelectric crystal as sensor. So piezoelectric crystal. So when the pressure is applied on the piezoelectric crystal, so due to the pressure, so there is a generation of voltage. Okay, so it consists of piezoelectric crystal clamped in a inherently sealed capsule which is subjected to the displacement stresses. So it's like a tube structure. The displacement is transmitted to the crystal through a soft rubber diaphragm. Okay, the pulse pressure waveform is recorded by connecting the crystal to ECG recorder. ECG recorder. So here we have a soft rubber diaphragm. So this soft rubber diaphragm, one end of this soft rubber diaphragm, we will connect the piezoelectric crystal, and another side is used to sense the pulse. Okay, so the volume of the blood in the finger varies during cardiac cycle, which cause changes in the size of the finger. So when the cardiac cycle means ECG waveform. When the ECG waveform is mean when the volume of the blood is changes in the finger, which causes variations in the air column inside the plastic rubbing. So okay, so by the application of the by placing your finger over the this soft rubber diaphragm, soft rubber diaphragm, so that makes a displacement of the rubber diaphragm, that makes a change of the pressure. That change in pressure will be applied over the piezoelectric transducer, which converts the pressure changes into electrical signal. So this electrical signal is amplified and displayed or recorded. So here, so we have a tube-like structure. So one end of the tube, we will place the our sensor, our object. Here, object is the finger. When the finger is placed due to the uh, due to the this cardiac cycle, so there is some pressure variations will be occurred at finger side, and due to that variations, so there is a inside the soft rubber tube we have a pressure variations will be there. That pressure variations will be sensed by the piezoelectric crystal, and when the piezoelectric crystal will senses those pressure variations through a rubber diaphragm, so it converts into the electrical form. So the output of the piezoelectric crystal will reflects, it will reflect the how much of pressure variations in the object. Here object means the finger. Okay, and that electrical signal is amplified and displayed or recorded. We can get the output in the form of displaying or we can record. And coming to next pulse transducer, that is strain gauge pulse transducer. Strain gauge pulse transducer. So here we have displacement of vessel wall is transferred to semiconductor strain gauge by means of a feeler pin and a leaf spring. See, I will show a figure to you. So this figure shows strain gauge pulse transducer. So here this is the leaf spring and this is the feeler pin. This is the feeler pin and this is the leaf spring. Okay, and one end of the leaf spring will attach the feeler pin and another end of the leaf spring we will connect strain gauge, one strain gauge. Okay, it will attach it to the leaf spring. Okay, so when we will place our finger on the feeler pin, so uh, we will place our finger on the finger feeler pin, so it will apply a pressure over the feeler pin and that applies the leaf spring and uh, that causes the feeler spin, there is a displacement will be occurs and that displacement will be identified by using strain gauge. So because strain gauge is connected to feeler leaf spring and leaf spring will be senses the variation of the blood variation which is placed over the feeler pin. Okay, so when the finger is placed at this feeler pin, so that will senses the blood pressure of the finger and that sensed vibrations will be applied over the leaf spring and according to the vibration of this leaf spring also moves and that change of the vibration or variation will be measured by strain gauge. This strain gauge will be this strain will be senses the variation of this leaf spring and due to that you will get the output. That final output will reflect that final output will reflect the how much the amount of. Okay, so that final output will reflects the amount of the blood flow, blood pressure in the vessels. Okay, so these are the uh, three methods used for the pulse recording, pulse sensing and recording. So by using photoelectric pulse transducers, piezoelectric atrial pulse receptor, and by using strain gauge pulse transducers, we can record the blood pressure in a finger or blood pressure in a finger. So coming to respiration sensor. In the respiration sensor, so tissues receive the oxygen and given away the carbon dioxide in the respiration system. So in the respiration system, the oxygen will be the oxygen will be received and the carbon dioxide will be released. Inhale and exhale process. By the inhale and exhale process, we can receive the oxygen and releases the carbon dioxide. When the oxygen is received, that oxygen will be received by the tissues. Okay, the breathing action is controlled by the muscular action, causing the volume of lung to increase and decrease. So when we have inhale, so the volume of the lungs will be increases. When we exhale, the volume of the lungs will be decreases. Okay, so in such situation, we have to identify what is the condition of the lungs, how ability, how much it will be able to inhale and exhale the uh, air. Okay, so what is the you have to know the condition of the lungs. So in such situation we have to use two types of transducers. So nowadays, due to the corona, so most of the lungs will be affected. So the doctor saying that your lungs capacity is decreased due to some infections. So that is possible by using these transducers. So they will use these transducers. They will identify the lung capacity. So or breathing capacity, how much they can breathe, how much they can able to breathe. Okay, so like that they can be identified by using these following transducers in the measurement of respiration rate. Okay, so the first one is strain gauge based chest transducer, and another one is the thermistor based transducer. So strain gauge type chest transducer means, so we can identify is here we will use a strain gauge, that is incorporating strain gauge. Okay, so hello. Hello. Okay. So in this case, so strain gauge we will use, and the strain gauge will be attached to the chest, around the chest, using some elastic band. Hello. Hello. Please, please off the mic. Some of the student. Please off the mic. Some unknown disturbance is coming. Sir. ఒకసారి రండి సార్. So by using strain gauge type chest transducer, we will use the strain gauge as the sensor. We will fix at the uh, around the chest. Okay, so the respiratory movements result in the resistance change in the strain gauge. So when we attach the strain gauge on the chest, so due to that, by inhaling and exhaling process, there is a respiration movements will be there, and those respiration movements will be converts into the resistance change in the strain gauge, and that strain gauge will be connected as one arm of the V-strain bridge, and the output voltage of the bridge varies with the chest expansion, which gives the signal corresponding to the respiratory activity of the subject. If suppose a patient does not infected, so in such situation he will be um, completely inhales and exhales, and due to that the respiration movements will be very high. In such situation we will get the output is very high. If any patient is infected some virus like that, so in such situation he is unable to um, respiration properly. So and the respiration movements was decreases, and due to that the strain gauge senses the decreased movements, and due to that the change of the resistance will be decreases. Due to change of the resistance there is a variation in the output, and the output will be decreases, and due to that Due to that decreased output, we can analyze that. So normal patient is much of variation, and if there is any affected, this much of variation that will be identified by using strain gauge type of chest transducer. And another one is thermistor based transducer. Thermistor based transducer. So in this case, we will use a thermistor placed in front of the nostrils using suitable holding device. We will use this thermistor in the nostrils. So if the difference in temperature of outside air and that of the expired air is small, thermistor can be initially heated to a suitable temperature, and variation of its resistance in synchronism with the respiration rate as a result of the cooling effect of the air stream can be detected. So in this case, um, difference of the temperature, suppose outside temperature is difference in temperature of outside air and expired air is small, the mist can be initially heated to a suitable temperature, and the variation of its resistance in synchronous with the respiration rate as a result of the cooling effect of air stream. So when the air is inhale and expel, there is a temperature variation will be there. So by identifying that temperature variation also, we can identify the lung capacity. So at the inhale and exhale process, so we will place a thermistor at the nostril point. So there we can identify the difference of the temperature. Okay. And transducers with digital output. So some of the transducers will convert the voltage analog form of the signal into uh, most of the transducers will produces the analog signal. So but to know the output, we have to use the analog to digital form to read in the digital nature. So some of the transducers are will produce the digital output. Suppose a transducer whose output is digital form uses encoding disks or rollers with a digital pattern and photographically etched on glass plates. So you can identify uh, digital form of the transducers. So they will directly produce the output in the form of digital nature only. Okay, so that digital form of the signal will be encoded by using